Hello everybody and welcome to today's tutorial. In the previous tutorial we did an introduction to KiCAD and it was a very nice video which we were introducing the shortcuts that are very important when doing KiCAD schematic. So in that video we did a small schematic. Let's get started. Where we left, it was new. We go to open project. Then we go to where we saved our project, desktop, articles, the engineering hub, introduction to KiCAD, like that, and then you open the project. Then you open the schematic. So this was the schematic in the previous video that we did, and okay, it's a very important project because it was introducing us to what we should do when using the shortcuts. So in today's videos we are going to do a simple project schematic. This one was more simple, but today we are going to do a project that meets the goals of engineering. This one we did how to power an LED using a 9 volts battery. So this 9 volts can be gained from even a 12 volts battery. That's why you had to put on a resistor that could prevent the blowing out of the LED. So we delete this one. So you select and then hit delete, and it disappears like that. So we get started with the new project, and in this project we're going to meet some few things, and therefore let me try to create some of the things that we are going to meet in this project. I'm going to introduce some of the important things that we are going to meet in this project. Now, in the project you're going to do, we're going to do a power supply system, and in this project we are going to meet some few requirements. Let's say we are going to power a power supply system using a 12 volts battery input. Our power system should have an output of 5 volts at 1 amp of current, and then our power system should use LED feedback. Then the same power system should have protection at both input and output. Okay, it should have a switch, an on-off switch. Okay, it should have an on-off switch. And then this power system, this one, the point number 6 will be met when we get to PCB layout. But today in this video we won't reach that point. We are just going to do the schematic and how to introduce the engineering aspects of electronics in our schematics. So we will be doing what we call we make the schematic, the system very small. So these are the things that we're going to meet during the design process, and therefore we have to get started. So from our schematic, we can see that we have a 12 volts battery input. We don't have any problem with this one because it's just an input. So we shall use a connector. We shall place a connector to meet this requirement because we shall be powering it from the battery. So we put a connector where our battery will be connected. But now we have our output, which is 5 voltage at 1 amp. This one is very, very important. For us to get this one, we are having 5 voltage as an input from the battery. And maybe the battery can give us more current depending on what we want to drain. But for us, we want to drain only 1 amp from this battery at 5 volts. So what do? You have to use a power management IC, LDOs. And LDO is very important to help us meet this aspect. So how do you know the right LDO to use in this schematic? To know the right LDO, you go to your Google and then you search for it. For example, today we shall be searching at DigiKey. DigiKey is one of the suppliers of the electronic components. We have so many of them. We have LC or S is partnering with GLPCB for manufacturing, and so many. But for this one, we are going to use DigiKey to search. And here at DigiKey, what you do, you search power management ICs, and we shall be looking for LDOs, a voltage regulator. We can also search it here, so there is no problem. So LDO, okay, and you can see it here. And we are looking for, of course, a single input, and then the maximum input voltage. We know is 12, but we want to concentrate on output current first. So on output current, we need 1 amp output current. So this must be met. So you search there 1 amp. So you can apply. We see how many of them are remaining. So far we have 15,862. So let's apply, and then we see what we shall be getting. We can still search it here. So single number of input. Then we want to concentrate on the current first, and on current so we can clear first, then we start okay, yes. So when you clear, you apply all first. On this side, we can go on 1 amp, 15,000, so remaining 4,000, and then it's 1 amp. But again, remember, maximum input, so we want an output voltage. Okay, and output voltage should be 5 volts. So you go to a point where you get 5 volts. Almost there. Output voltage should be 5 volts. So you can apply. We see how many will remain. We were at 42, 45. So I can reset this one. We see what is remaining at, again, it's still at 0. So at 1 amp, we don't have anything for 5 volts. Okay, so we can look at it, this one, DigiKey. For DigiKey, we start at current, and we said we are going for 1 amp current. Okay, then we apply. We see how many will be remaining at the end of everything, because we were at 873. Let's see after the search. Okay, for this one we said current, and then we said output voltage should be 5 volts. We need fixed voltage, so 5 volt is a must to be met. Okay. Oh, 5 volt is here. We can apply, we see what we get. On the other side, we have 125 remaining on the results. So we can go to voltage output maximum fixed, exactly. So maximum minimum fixed. Okay, 5. Okay, let's put something. Voltage, okay, minimum, maximum. So minimum fixed, can look for 5 volts. Let's apply and see what we'll be getting. So you have 18 of them remaining in stock. You can see here results, 18 remaining in stock. So what else do we need to add? I don't think we have anything we want to add. Here we had selected some other things, like they must be in stock. They must have a data sheet. They must have a photo for us to see. So these requirements, you can see them here. So the first one is here. It's LM2575T 5G, and this one is from Rochester Electronics. Then we have this one from LM2575T 5 volts. This one is from Texas Instrumentation. Then we have this one, LM again. It's from Texas Instrumentation. You can see the price. This one is at $5.6. This is at $5.88. Okay, we go on. We look at others. Texas Instrumentation again. Okay, you can see it's a power management IC, $3. You have another one here from Analog Devices International. Okay, Analog Devices, and so on and so on. So there are so many of them. This is again from Texas Instrumentation, LM2595. Yes. So this one, we have to select the best for this project. And to select the best, what you do, you go to, let's start with this one from Texas Instrumentation. Let's look at the data sheet. Let's see what they have in their data sheet. The reason why we are looking for these systems is to look for the data sheet and see what is happening. So this is the data sheet. And in this data sheet, you can see we have a circuit that will guide us through this system. So this one, it has an input voltage of 7 to 40. But now we wanted an input voltage of at least 12 voltage. So we can come here. Where is it? Input voltage. And try to do some adjustments again. Input minimum, input voltage maximum. So we can take an input voltage minimum or maximum of 17. Then we can apply and see how many. Yeah, you can see 2 remaining now, because we are powering it from a battery, and battery can have a voltage surge of up to 16 volts. So for us to be safe, we take a voltage of up to 16. So in stock we have 8, we have 4, so not bad off. Okay, this is an IC, so LTC 3621. So after doing that, let's look at DigiKey, whether we have such a component. So we come and input. Okay. Don't ask me again. So let's see. let's get started. Okay. So LT, I've seen it's LTC, that is 6, LTC, that is 621, LTC 3621. So we don't have such component. Okay, we can try again and look for another one. We can LTC 26. So that one is not available. So we can change. We can do some adjustments. We can do some adjustments. Can try to do some a few adjustments here and there. Let it load. For this one, we had 110 remaining in stock. And then maximum output. So we can filter here again in stock. We see how many are in stock. So we can use this on LM2575. Let's see, LM2575, whether it's there. Because you can see the voltage can be between 7 volts to 40 volts. Still it falls in between where we need LM2575. 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 Yeah, you can see it's there. But now we need to use the one for 5 volts. So we have this on 5 volts fixed. Simple 1 amp back convert regulator. Okay, well, a high voltage fixed simple 1 amp back converter back regulator switcher. So we can have this one and click. That's a switcher. On off again. This one is a switcher. Let's look at the schematic here. Where is it? Okay, we have this one on off. They are grounded, correct? So you come back here and pick this symbol. So you can use this one, the first one, 50BT. So that's our voltage regulator that we shall be using. And then you have to copy this schematic as it is. This is how it's powered. So it's very important and necessary to use this schematic. So we have a capacitor here, we have ground, we have capacitors, and everything is grounded. So let's get started as quick as possible. So we have to place symbols in. Okay, capacitor, CP1. We want to use polarized capacitor. Okay, we place it the first one there. You copy it. I showed you the shortcuts. You place it there, and then we have an inductor. So inductor, inductor, and I think there is small, or there is not small or very large. Inductor is inductor. You place it there. Then what else do we have? we have a diode. Okay, this one you move M like this, it's supposed to be there. Then we have a diode, we have a stocky diode. So stocky diode small, I'll use it there. So rotation R like that. Then we come back to schematic and see. So you have this one, we have this one, we have this one. Okay, so we have everything. So it's only to edit the values 100, 330. So this one value 100 UF. Then this one edit this one value 330 UF. Okay, and then what else do we have here? Let's see, this is 330 UF, 100 UF, this is 330 microhenry. So you come to inductor V 330 microhenry. Then now you start doing your connection as it's supposed to. This one you can move it to this point. You do wire, come and connect. Okay, wire again, come and connect. Control save. We check what is happening here. So that one will go to this feedback. So we can select everything. Then we move. Then wire. Connect this one like that to this point. Control 7. Let me confirm whether it's like that. Yeah, we are good to go. Then we have this one at the input. Then we have now to place a component G and D ground. Yes, ground. And in this ground, we are going to ground so many components. So I can copy here, ground there, copy here, ground there, copy here, ground there. So this one, sorry, wire W. Okay, escape. Like that. Sorry, not junction. Wire, enter, wire, enter, wire, escape, move, wire, enter, wire, enter. This one again, come here, we ground. So control save. So you can see this is we have powered our schematic like this. But I want to add some capacitors. You know, the more you add, you filter the signals, the more the signals are free of noise and vibrations. So I can add another capacitor. This one, copy. Place there, then wire like that, then a wire like that. This one I will edit, so the value, and make it 0, make it 10 UF. Then on the other side I'll add another capacitor, but this time I'll be using a different type of capacitor, which is non-polarized capacitor. So C1, C, then you go to small. Okay, here, and then I will do wire. I'll do wire, then I'll do ground. And in this this one I'll edit the value to 0.1 UF. So the more the capacitance, the more smooth your schematic becomes. So this is the first bit of our schematic. We have already shown, so here we shall be having an output of 5 volts. So I can attach a power tab here to show. Okay, 5 volts. Attach the symbol here to indicate what we are getting. So that one is 5 volts. So at the 5 volts, so we have made the first need for this system, whereby we need the output came at 5 volts at 1 amp. Okay, now we want to add other things. Okay, we want to add an output connector and input connector. So you can come back again here and see what to do. So component. So so we need to put a connector 0.1 times 0.2. So connector is there, rotate. I can mirror it along y-axis like that. Then I can copy it, place it on the other side, then mirror like that. Then we do the connection. Connect wire. Copy this ground. Wire W. Then you move with this ground. Wire. Copy. Then delete this one. Then we have this one. Control save. So we have the input here and the output. You can add some nodes and then you can add some nodes. Here. So you can call it input 12V. Input this one. Then you can add the other one here, which is 12 volts, which is 5 volts, 1 amp output. So the system is going on very well. We go to the next bit of the schematic, and the next bit is all about use of LED feedback. So you need to add an LED feedback to our system. Okay. So to add LED feedback, you look for component. So you place component LED, but now small. Here we go. Yes. Rotate R. So we need to use a resistor so that we can prevent this one from blowing off. So resistor can use small but British symbol. Then I can add a ground, copy this one, place it there. Then you can add a power. You can add power because you need to power it. Copy. This way we want to add the feedback. Of course, the powering is 5 volts from this side. And you do the connection. Wire. Control save. And this is all for the LED feedback. So we have added the LED feedback for our schematic. So we have an LED feedback for our schematic. Okay, now we need to meet another goal, and meeting the other goal is protection at both input and output. Anytime you hear about protection, think about fuses. So you have to place a component, a fuse, because we need to protect our system. So fuse, I can use fuse, but a small fuse, this one. Okay, so you see what I'm going to do. We have a line here, but anytime I place this component at this line here, you will notice the line will break. Let me expand it. You can see. There is a break on this line. So let me drag these ones. G for dragging. G for no. This one is dragging everything, including the wire. Let me say this one. G. So I can move, I can drag G. Very nice. So we have a fuse. I can copy this fuse. We want to protect the input and the output also. So for us to do that way, so we protect the input and the output. Exactly. Control save. Okay, now we have finished on circuit protection. Our circuit is very safe, it's protected. So the final bit now, we need to add a switch for our schematic to be complete. We need to add a switch for our schematic to be complete. And to add a switch, this is how you do it. You look for the component again, and then you look for a switch. But I can use a symbol for switch SW. Then I look for the switch I want. So I can use this one because I just need a single switch. So switch deep times 01. Yep, this one is correct. Then I place the switch at the input. I was not specific on where we need to place our switch. I was not very specific. I just said a switch. But let me say it's a switch at the input. But if they have not been specific, you will have to input a switch at the input and at the output. Input is written like this. So you will have to use a switch at the input and at the output. So this is all about our circuit, what we needed to do. The rest of the remaining of the things will be done in another bit. Control save, our schematic is done, and I wish to thank you for cooperating in this video. Bye bye, see you next time.